Hi guys, and welcome to Miss B's classroom. I just wanted to tell you that today we're going to be learning a new method for solving systems of equations. And this is probably one of my favorite methods because while substitution can kind of be tricky, you're working, going back and forth between equations, elimination, as long as it's set up easy for us, is a really easy method and it doesn't require us graphing. So let's take a look at it. So in order to solve a system of equations using the elimination method, you need to add equal expressions to get rid of one of the variables. Next, then, you solve for the second variable. And then you need to use that solution to solve for the final variable. And by final, I mean the first variable, the one we didn't use. Okay, so let me read through this again as you're still copying it down. To solve a system of equations using the elimination method, you need to add equal expressions to get rid of one variable. Then you need to solve for the second variable and use that solution to solve for the first variable. Very wordy, right? All right, well, Miss B is going to make it really easy for you. All right, so if you have this definition down, I'm going to go ahead and erase it. If not, pause the video because I am going to erase it. All right, so the elimination method. This is kind of fun because it's just like adding and subtracting, and we only have to manipulate the problems a little bit. So, before we start though, I want to go over something with you. If I said, what is 5 plus negative 5, what would you tell me? You're right, it's 0. Why is it 0? Because it's plus the opposite. If I have my number line here, and here's 0, 1, 2, 3, 4, 5. If I go up positive 5 first, and then I'm adding a negative 5, that's telling me, wait, you have to go back in this direction. That puts me at 0. So they cancel each other out. That's what we're going to be trying to do in our systems of equations. So I'm going to keep this up top to help remind you. So the first one on your notes is the equation 2x plus 3y equals 18, and then 5x minus 3y equals 3. All right, so I'm going to be looking for something that I can cancel out. If you notice, my 3y's are actually opposites of each other. All right, 3y plus negative 3y, it's going to cancel out to 0, just like my example up here. So the coefficients of y are additive inverse. That's what we call them. These are additive inverse when they equal 0. So the equations, I want to eliminate y. So let's take a look at this first. So I'm going to add the two together. So, when I add these equations together, I already know that these are going to cancel out. But my x's don't cancel out. 2x plus an additional 5x is 7x, and 18 plus 3 is 21. When I add these together, I have a simple one-step equation. because we're multiplying, I need the inverse operation, which is dividing by 7. And if I do it to one side, I have to do it to the other. When I divide by 7 on both sides, I figure out x equals 3. All right? Okay. Now that I know that x equals 3, I'm going to substitute that in. So we are doing a little substitution. And then I'm going to solve for my y. So it doesn't matter what equation. I'm just going to pick the first one. All right. And yeah, I'll do it smaller. I'm going to do 2x plus 3y equals, I'm just going to write this a little smaller, x equals 3, equals 18. Since I know x equals 3, I'm going to do 2 times my 3 plus 3y equals 18. This is helpful because when I do this, I can see that I'm only working with one variable now. We end up with 6 plus 3y equals 18. All right. If I subtract 6 on both sides to try and isolate my variable, I'm going to get 3y equals, I'm going to get 3y equals, why are you having trouble? Must be, it equals 12, I'm sorry. Woo! Okay, so now it's an easy one-step equation again. I divide by 3, I divide by 3, y equals 4. So now I have a solution. I have x equals 3 and y equals 4. Now we know that we write our solutions in a point formula, 3, 4. So if I were to write these or graph these equations, the lines would cross at 3, 4. So there is one solution for this problem. Now, after we have solved for our first variable, we substitute that in for our second. The final step is to check. So let's just do our check real quick here. And that's just making sure that when we plug in our point that we are getting, oops, it's not a good day for me. We are getting the correct answer. So we said that our point was 3, 4. So we need to plug 3 and 4 into each equation, make sure it equals it. So we have 2x plus 3y equals 18, and then we had 5x minus 3y equals 3. All right, so let's plug in our variables. I'm going to do 2 times 3, all right, plus 3 times 4, and we want to know if that equals 18. And then I'm going to do 5 times our 3, and then minus 3 times our y, which is 4, and we want that to equal 3. If they check, then we're good to go. All right, so 2 times 3 is 6. 6 plus 12, does that equal 18? Yes, 18 equals 18. It checks. Over here, 5 times 3 is 15, minus 3 times 4, which is 12. Does that equal 3? Yes, it does. So since both equations check, I know my answer is right. Okay, what I want you to do now is I want you to pause the video and try the quick check on your own, following this same process. All right, so the quick check. You were given two systems of equations. You were given 3x plus 4y equals 16, and then negative 3x plus 2y equals 8. All right, so what was our common, or the variable we wanted to eliminate first, hence the elimination method? Good, it was 3x because they're additive inverse, they're opposites. So when I add these two equations together, they cancel out and I get 6y equals 24. I can easily divide by 6 with a one-step equation and I get y equals 4. Easy peasy, right? Then all I have to do is plug it in. 3x plus 4 times 4 equals 16. I get 3x plus 16 equals 16. Now this is where you might have been a little nervous. Well, okay. I have to do the inverse, so I'm going to minus 16. What happens, though, on this right-hand side? You're correct. It goes to 0, and that's absolutely okay. 3x equals 0. If I divide by 3, 0 divided by 3, we get 0, so x is equal to 0. That's a possible point we can have, 0, 4 on our graph. So our final answer is 0, 4. I hope you got that. If you did, give yourself a pat on the back. This is going to conclude video 1. Next, I want you to go ahead and watch video 2.